Alright, this could be our next notes in geometry. This could be lesson 8.3, and here we're going to be looking at some special right triangles, specifically some 45, 45, 90 triangles and some 30, 60, 90 triangles. And there's going to be some special properties or special dimensions of these that will help us solve for triangles that we don't know the sides of. So first, a 45, 45, 90 triangle. This triangle is formed by the diagonal of a square. So if you remember a square, you probably remember this. All sides are the same length. And then if you draw a diagonal, this would be, on each side would be 45 and 45, and then this side would be a 90. So as a result of this, every square is going to form two 45, 45, 90 triangles. Okay? And there's a theorem that goes along with this that helps us figure out some lengths of it, because since it's a right triangle, we can use the Pythagorean theorem. Okay, and we also know, because this is a square up here, these two lengths are the same length. And then, so how can we figure out what the hypothesis is? Is there an easy way to use the Pythagorean theorem to create an equation then that can just give us the equation we can plug in? Well, here's how it works. So if we know a squared plus b squared equals c squared, we can also just plug in, we know a squared is L, and b squared is L, and then c squared is h. We can just turn a squared plus b squared plus equals c squared into L squared plus L squared equals h squared. Then we add like terms, right? L squared plus L squared is 2L squared. And then with that, then we have h squared over here. We need to take the square root of these, right? When we do that, we can then pull the L out, because L squared, the square root of that is L, and we're left with L times the square root of 2 is h. And that ties into our triangle theorem. And this just says, what we just solved, in a 45, 45, 90 triangle, the legs L, right here, are congruent, and the hypotenuse is equal to the length times the square root of 2. So if we have this kind of triangle, we want to know what the hypotenuse is. We just figure out what the length is, multiply that by the square root of 2, and we'll have the length of the hypotenuse. So that's that one there. So if we use what we just learned to figure out what some of these lengths are, using that equation we just have, so let's say we have this 45, 45, 90 triangle here, and we know it is because it's a right triangle. If this one's 45, this one has to be 45, because the whole thing has to be equal to 180. Okay, and then we know here it wants to find out x, right? And x is the hypotenuse. So if we just plug in into this equation, h equals L times the square root of 2, we can figure out what the hypotenuse is. So let's do that. So h is L, which is 6, times the square root of 2, and we could do some figuring with the square root of 2 times it by 6, but for right now that's that. Okay, so if x is equal to 6 times the square root of 2. Okay, there's another thing we can do with this as well. We can also figure out the leg length as well. So before we did hypotenuse, which is 12 here, well, how do we figure out what the leg length is? So here we'll just plug our numbers into the same equation. So here we have hypotenuse is 12. That equals the length, which is x, times the square root of 2. Then we want to get x by itself, so let's divide both of these by the square root of 2. Okay, then we're left with 12 over the square root of 2, so move that up, equals x. And then to fix this, because we can't have a square root on the bottom of a fraction, we're going to multiply this whole thing by the square root of 2. Do them both. Okay. Then the square root of 2 times the square root of 2 is going to give us 2 on the bottom. I'm going to write it down here. Then it's going to be 12 times the square root of 2 equals x. And then to simplify this, 12 divided by 2 is 6. Square root of 2, that would be each of our lengths, our leg lengths, just using this equation. Okay, so that's our 45, 45, 90 triangle. So also we can do some properties for the other triangle. This is a 30, 60, 90 triangle. Okay, and this is formed from an equilateral triangle, and I'll show you how this one kind of forms. So here we have this equilateral triangle, which is a 60, let me move this over, that's sunlight. This is going to be, so this equilateral triangle is going to give us a 60, 60, 60 triangle, and all these sides are equal, right? Well, let's just put an altitude right here. Okay. So then we know we have a 60, a 90, so then this then becomes a 30, instead of a 60 total, it's a 30, 30 in there. Okay. But then we know if this is an equilateral triangle, and we have this cut in half here, then this would be x and x. Okay. And then we know the whole length of this is 2x. But then we also know in an equilateral triangle that all these sides are the same, right? So then we know that this is 2x, and this is 2x, right? So then we have this triangle, this hypotenuse 2x, this leg here is x, and then we just need to solve for a. Okay, and again we can come back to the sunlight. We can come back to the Pythagorean theorem. So if we plug that in, that's just a squared plus b squared equals c squared. Our c squared would be right here, and then we would have a and b, right? So if we plug that in, so our a squared would be right here. Let's call that a squared. And then b squared would be right here. So we'll call that x squared. And then here we have c squared, which is 2x squared. Okay, and I'm going to move this whole thing over here. I got to do a few calculations. A squared plus x squared equals 2x squared. Okay, so then I'm going to use a little math here. And I want to show you here too, I kind of made a small mistake here. So make sure you correct this. This is really 2x squared. So this should be square 2 to the second power, which would be 4. So we go back. Okay, and then so I'm left with a squared plus x squared equals 4x squared. So then I'm going to get a squared by itself by minusing x squared from both sides, collecting like terms. So a squared equals 3x squared. Okay, right there. So then again, I'll just get rid of this x squared, so if I want to figure out what a is, so then I'm going to do the square root of a squared is a, and the square root of 3 can't do anything in that, but I can do the x, because x squared, the square root of that is x, so a equals x times the square root of 3. So if I then know x is, whatever x is, I can then figure out what a is. Okay, so this is kind of a formula that you will use as well, so you might want to note that somehow. But if we finally look here at the theorem and what it really says, it says in a 30, 60, 90 triangle, the length of the hypotenuse h is 2 times the length of the shorter leg. We can see that here. And then in the length of the longer leg L is square root of 3 times the length of the shorter. Okay, we kind of figured that out by doing this Pythagorean theorem. And that should kind of do our notes. We'll do a couple practice problems in class with these as well. And just add these to your notebook, and I'll see you in class.